Thank you for clicking on the help video. In this example, we have that the polynomial function is represented by this graph right here, and we want to identify the x-intercepts to this graph, then determine of those intercepts which is going to have an even multiplicity and an odd multiplicity. Well, I'll start with part A. Our intercepts are going to be where we cross the x-axis or touch the x-axis. So these are going to be our x-intercepts, our zeros. So x equals -2, x equals +2, and x equals 4. Well, what are going to be the multiplicities to these intercepts, to these zeros? Well, because at this intercept, we are intersecting, again, we're crossing the x-axis at that location. Along with this one, we are crossing the x-axis. We're moving from above to below it on the second one and moving from below to above. Those two places are going to have a multiplicity that's going to be an odd. It could be 1, it could be 3, but it's going to have an odd multiplicity. And because this 0 here is tangent, this is the only one that's tangent, the one right here in red, that intercept, that 0, is going to have an even multiplicity. So to determine where the graph has an even integer as a multiplicity, an even multiplicity, we're looking for when the graph is tangent, and an odd multiplicity means that the graph is going to cross the axis at those values. So here's because we only have one place where the graph is tangent at +2. +2 is going to have an even multiplicity, and x equals -2 and +4. At those locations, the graph is going to have an odd multiplicity, meaning that x will equal to -2 an odd number of times, and the same thing with 4. I hope this explanation was helpful, and I appreciate you watching.